Howdy everybody, my name is Cameron Church and I am a student at Washington State University, and today I am going to teach you how to do linear regression in Python coding language. So the reason why I'm using Python is there's a lot of benefits, and plus it's also becoming a market standard to know how to use Python specifically for linear regression, especially in the financial world. And so today this is just a small skill, but hopefully if you enjoy it or if you like what you're able to do with it and the capabilities of Python, maybe in the future you might want to learn something else in Python like multivariate regression, which is also pretty common in finance as well. So to get started today, we have to do a couple things first. First, we have to download our environment, which is what this is, and I'm going to show you how to download all the software that you need to start coding in Python. And I'm also going to show you where you can get data, or at least where I get data, and show you a couple other examples of like where you can get some of this equipment. And then after that, we're going to explain a little bit that you need to know about Python, kind of explain what our environment is real quick, and then we'll actually get into the coding. One thing to keep in mind is that this video is not this is not like a Python tutorial. It's very specific, as in a linear regression using Python tutorial. So I'm not going to be teaching all the nuances that are in Python. I'm not going to be talking about all the methods and classes and what those are and how they work. I'm simply going to be teaching bare bones, just how to do linear regression for stock analysis in Python. So if you're looking for something else, or if you're looking for something that's like a little bit more advanced, or you really want to understand some of the stuff, this may not be the video for you, or this might just be a starting video and you may want to look up some more information afterwards. So first of all, we're going to get started and we're going to create our coding environment. And so the first thing that we need to do is download that. So I use Anaconda. Anaconda is a free software that you can download from the internet. It's pretty popular as well, especially for data science. It's pretty much made for data science. And what's nice about it is, one, it is free, it's pretty accessible, but also it has several different environments that have several different uses. So one might be for data science, specifically for like analysis. One might be for machine learning. There's a bunch of different environments, and you'll see that when we open it up. But first, to download it, just go to downloads, or anaconda.com/downloads. This window is kind of unnecessary, but just anaconda.com/download, and this is what it should look like. And then you can pick whatever system you're using. I'm using Windows, but if you're using Mac, they have one for that as well as for Linux. So just download the newest version and then let it set up. It may take a little time. It is kind of a big file, so just give it some time. It's pretty easy to set up though. You'll just run it, execute it, and then it'll do pretty much all the work for you. So then once you're done doing that, you can go to your search bar or to your Finder and just type in Anaconda, and Anaconda Navigator should be the first thing that pops up. And when you do, you'll click that, it'll open up, and this is what will appear. And this is kind of like your general board where it can show you some of the other IDEs that they have. And so as you can see, there is some like Jupyter Notebook and Jupyter Lab. Those are pretty popular, again, for for analysis. RStudio, if you're really interested in using R language instead of Python. I am going to be using Spider, which again is basically just another studio, but just for Python, and it is really tailored to more like just general data analysis. So you'll click launch, and then this is the screen that will pop up, and it may look a little different, but for the most part it should be the same, where you have like a big open area for your code. This will be your kind of like your folder setup or your folder window, and this will be your actual console where you can actually like run and execute your code. And so we'll explain all that in a little bit, and you'll see what it all does later. But before we even get started in that, we also need to download our data set. And so to download your data, there's a bunch. You can go really anywhere. You can go to the NASDAQ website. I prefer Yahoo Finance. I just because like the way it downloads for me is pretty simple. The two sets of data that we're going to download are the Boeing company, so that's right here, and then the S&P 500, so that's our index that we're going to compare our stock to. If you're looking for a stock and it's not like automatically set up there, you can just go ahead and type it into here. So like I'm just going to type in Boeing again, and Boeing is right there. That's the first one. And as you can see, it's just general information. It opens up to its summary. But then if you go to this tab right here, the historical data tab, it'll show you all the daily information from the past, whenever, for this stock. So for this one, it shows the past year's worth of stock, and it's the daily. You can change that if you want to make it weekly or monthly. You can also look at like dividend prices and stock splits as well. We're not going to worry about any of that. We're just going to keep this all the same. The only difference is that we're actually going to download 3 years of data, at least for me. And again, you can change that to 3 years, 5 years, 2 years, 1 year, a month. It's really up to you. But again, I'm going to go ahead and change this to 15. Done. So that's 3 years total of data. Hit apply so it updates. and then just click download the data. And so as you can see, it downloads right down here, and it is a .csv file, which for our purposes today is really useful. You can download it in an Excel file too. There are other ways of going about that. You just have to add a little extra code, but today we're just going to be talking about the CSV. So if you can take your Excel file and convert it into a CSV, that's a lot helpful. That's going to be helpful for today's video. If you prefer to do it in Excel, there are plenty of tutorials online to do it in Excel as well. It's just for me and for the purpose of this video, it's just easier to teach only with using CSV files. Then, so there you go. So we have our data, and then lastly, we're just going to again download our stock market, or our index that we're going to compare it to. So again, I used S&P 500. You can use NASDAQ or Russell 2000, doesn't matter. But to get the data set, it's the same way. Just go down to historical data, change it to the same dates, make sure that it is the same dates as your individual stock that you're comparing it to. Done. And then hit apply, and then download the data. And again, so once that downloads, will it download? Okay, let's try that again. There you go. So there you go. So now it's downloaded. Those are our two data sets. As you can see, their names are really weird. They're just their symbols, their stock symbols. I actually went ahead and saved these already into a file, and I just renamed them to like their stock. So I would highly recommend this, because if you can eliminate like spaces in your names, that really helps your code, because sometimes spaces can kind of mess with your code. Also, it's easier if you put everything in like lowercase, because Python is case sensitive, which we'll talk about in a little bit, but having capitals can sometimes mess up your code as well. So keeping the names as simple as possible, and just saving them in the same file, in whichever file you want. And then after that, we'll be able to open that all up in Spider, which we opened up earlier, and then we'll be able to do our data analysis. Okay, perfect. So now that we have our data sets, they're kind of conditioned to be a little bit better for our stuff. In our Spider, now that we're back into our IDE here, we can save this file. So as you can see, this one isn't saved yet, but if I hit Control S, it'll open up a random folder, and I highly recommend saving it in the same folder as your data. So as you can see, it's opened up right here. I'm just going to save it as practice_regression.py, and it's important to make sure that you do add that py at the end, because as you can see, it's only set for supported text files. I'm not sure, you can go ahead and save it as a Python file if you wanted to, or you could just keep it that way. Just make sure that at the end it's saved as a .py file, .py file, because if it's saved as like a .text file or something like that, then when you try to run it into your code, it's not going to work. So whatever way that you do it, just make sure it's saved as a .py. So hit save. So as you can see, it's saved as practice_regression.py. I'm just going to Control A and delete all that, because we're not going to need that. And so there is that. The last thing that we need to do before we get into our intro into Python is just simply make sure that our folder is set to our data set. So this is the name of the folder that I have all my data and my file. As you can see right now, it doesn't show the information, but if we hit select folder, then we go to File Explorer, we can see that it's set up there. And here's our folder that we're working with right now. And since all this is in the same place, it'll make it much, much easier to do our analysis. So before we get into Python, there are just a couple things that we have to talk about Python just to be aware of, because when you're typing in Python, sometimes you might have some glitches or some bugs in your code, and they're usually really simple issues that you can fix really quickly. It's just something to keep an eye out for. So the first one is that I mentioned before, Python is case sensitive. So it's okay to work with capitals, it's okay to work with lowercase, obviously. It's just make sure that if you label something with a capital letter, make sure that you also remember later when you reference that code that it's also in capitals, because panda, like panda, the word panda, oh gosh, the word panda and capital Panda to Python are two completely different things. So, and that's not just because panda means something and capital P panda means something. It's just that, like, since they're spelled differently because they have different letters, technically, they're different things in Python. So something to keep in mind, especially if there are some functions that we have to call that do use capitals. And so if we forget those capitals, it'll be like, I can't find this function or whatever because you're not using capitals. The other one is that Python starts at 0. And so when we're counting things and like counting columns and counting rows, they're like, you could have 1,000 rows of information or data, but Python's going to read that as 999 rows of data because it doesn't start at 1 and go to 1,000. It goes from 0 to 999. So that's something to keep in mind, and we'll bring that up a little bit later when we're talking about selecting columns and choosing our specific information. and like selecting the data that we want to use to analyze. But just keep that in mind. So if you're like pulling in random columns of data and it's like, I thought this was the right column, you might want to check again, because sometimes, you know, you might have to subtract a number from the column that you're referencing to make sure that you're pulling the right information. And then the last one, contrary to what you might think for the rest of this video, I'm not going to explain everything in this video. As I mentioned before, this is really has a specific purpose. I'm not trying to teach you how to use Python or how Python works in general. I'm just teaching you this one practice in Python and how to make it happen. So there are going to be some things that I just type in here. You don't have to worry about how it works. Just trust me, it'll work. If there is something that you know, for you it might be different, I will explain a little bit. For instance, when we're talking about like changing columns, like if you're using a data set and I use this number column, but you use this number column, I'll show you how to change that and like kind of tailor Python to work for you. But yeah, so I'm not going to go into all the itty bitty details and like how Python works, because that's not the purpose of this video. Okay, so now that we've gone through all the introduction stuff, let's go ahead and start coding. So the first thing that we need to do is import libraries, and libraries is just code that someone else wrote that we're going to use, and it's going to make our lives a lot easier. So first we're going to import NumPy is the first one, NumPy as NP, import pandas as PD, and import, this one's kind of a long one, matplotlib.pyplot as PLT. So again, this is just code that other people wrote and it's stored in a file, and these NumPy, pandas, and matplotlib.pyplot are the files that they're stored in essentially. So, and then this as part just lets us say like, oh, instead of having to type NumPy every single time we use it, we can just type NP. Or instead of typing matplotlib.pyplot every single time that we use it, we can just type PLT and it'll do the same thing. Okay, so those are our libraries. The next step is to import the data set. And so as I mentioned before, we have two sets of data. We have the Boeing CSV and the S&P 500 CSV, or your stock, and then whatever index that you used to compare it to. So what we need to do after this is import them separately and create our X and Y variables in our data set. So the first data set we're going to pull in is Boeing. And so, Boeing, I'm just going to create a variable, Boeing equals pd.c or read_CSV, and then parentheses, then double apostrophe, and in between the apostrophes, we're just gonna type in this this CSV file. So I say Boeing.csv. So if this is like running, so like actually let's go ahead and highlight all of this and hit Control Enter. And as you can see, that executes it into our console. It's running it. If you get an error saying Boeing.csv cannot be found or something like that, or your stock cannot be found, then you need to make sure that this folder is associated with the folder that has all of your information in it. So now that we have that, let's go ahead and look at our Variable Explorer. So our Variable Explorer creates variables as we execute them in the code. So Boeing, when we say something equals, we're creating a variable. And so we just created the Boeing variable. And if we look at it, it's literally just our entire data set that we plugged in. So if we were to open up our CSV file, we'd look at it, it'd look exactly the same as this. And that's what Pandas does for us. And so, as you can see, there's a lot of information here. This is the daily information of our stock. However, when we're doing a linear regression on a stock compared to the market or the index, we don't need all of this information. Like, we don't need the volume of stocks. We don't need the open or the close or the daily high and low. We technically don't even need the date. We just need to make sure that the adjusted close is in order, because all that we need is the adjusted close, because it's basically the close adjusted for things like stock splits and whatnot. So, so when we're making our X variable or our Y variable, we don't have to worry about any of these. So we can actually just select this one column of information. And so I'm going to show you how to do that. And again, this is going to be some code. I'm not going to explain it all. Just copy it and just trust me, it'll work. So we're going to say Y equals, because this is going to be our Y variable, Y equals Boeing dot iloc. Sorry, iloc. It's like, what am I typing here? So we're going to type in Y equals Boeing dot iloc, and then say colon, comma, 5:6, and then follow that up with dot values. And so I'm not going to explain all of this, but basically we just called our variable. So if you have a different variable here, just copy that here. So if you were doing like Intel, you'd just say Intel.iloc or something. This right here covers the rows in the data set. So since we're not putting any numbers here, we're just putting a colon. That's like saying we want all of the rows of data. And if you wanted specific rows, like, rows from 0 to 10 or 0 to 9, you could just put 0:9. But since we need all of them, we're just going to put a colon and it just reads as all of them. So right here, we're going to put 5 to 6 because, again, if we look at our data frame here, we can see that this is technically our 5th column, remember, because this is column 0, 1, 2, 3, 4, and 5. So we need the 5th column. And a good practice to have is instead of just, we could just put 5 here, but sometimes that does mess up the code for reasons. And so don't worry about like what I'm putting here, but if you are like using a different column, for instance, let's say you're using column 3, what you might want to do is instead say column 3:4, or if you're using column 7, use 7:8 or something like that. Don't worry, even if there is no 8th column or there is no 6th column or there is no 4th column, don't worry about that. Just go ahead and put the number after this because it just works. It's hard to explain, and there's really no point in explaining it. It works. So then after that, we can go ahead and actually, why don't we go ahead and execute this real quick? So again, Control Enter or Command Enter if you're on Mac. And so there you go. We actually created our Y variable. And if we look at our data frame, we can see that it is exactly the same as our adjusted close. It's just instead of having all these extra columns like the date and the open and everything, it's just our one column that we want. And so again, 132.52 is our 0. 133.04 is right there. So as you can see, this is just that column. Perfect. Okay, so now that we have our Y variable, we need to create our X variable. And again, it makes sense if you're just thinking of a graph, we need our X variable and our Y variable in order to plot it onto a graph. And so our Y variable is actually going to be our S&P 500 adjusted close. And what's cool about this is we can literally just copy what we did up here, except we're just going to change it to S&P 500 instead of Boeing. So SP 500 equals pd.read CSV. There you go. And parenthesis, double apostrophe, and then we're going to say sp500.csv. Perfect. And then instead of creating a Y variable, we're actually going to create an X variable. So X equals sp500.iloc : 5:6. And since this is from the same, since we got our data sets both from Yahoo Finance, we can pretty much assume that they are in the same format. But if you're not sure, what you can do is just highlight the one line, again, Control Enter. And then if you go to Variable Explorer, we've created your SP500 data set, and you can go ahead and check. So, okay, we're looking for 0, 1, 2, 3, 4, 5th column. So yeah, it's still the 5th column. We don't have to worry about it. If you're using data sets from like 2 different sources, you might want to check that just in case, because like they might, take out the data or put the data at the end or something like that. So just is good to check. But since we came from the same source, we can pretty much be assured that they're in the same format. So values. Okay, so let's go ahead and execute this one. So there you go. As you can see, we now have an X variable as well. So the next step that we have to do is create a training set and a test set. And that's a lot to understand. That's more of like when you go into like talking about data science and talking about statistics, you'll understand why you want to have a test set and a training set. I'm not going to explain it. Just go ahead and copy what I'm doing here, and it should work for your data set. So the first thing that we're going to do is import another library, but we're going to do it a little bit differently this time. So it's from sklearn.cross-validation import train underscore test underscore split, and then x underscore train comma x underscore test comma x underscore y underscore train comma y underscore test, and then we'll set equals, and we'll call this method up again. So it's going to be train underscore test underscore split. And then in parentheses, we're going to set a couple of parameters. And so one thing that you can actually do is if you're calling a method or something and you're not exactly sure how it works, you can hit Control I and in your help it'll actually show you like what it does, what it is, and it even tells you like what you need to type in. So we need to type in our arrays and our test size. We can actually go ahead and ignore train size and stratify, but we're actually also going to talk about random state, and we're going to set it to 0 as well. But so our arrays are just basically our data sets that we're going to be referring to, and since we've already created our variables, we can just go ahead and use x and y. So x will be our first one, x, comma, and then y will be our second one. Then again, we need to set our test size. So test underscore size equals, and we're going to say 0.2. And what this means is that we're going to take 0.2 or 20% of our data, and we're going to create like a test size or a test sample. And then the other 80% is going to be in our training sample. And so what our computer is going to do is it's going to take the training sample, the 80%, and it's going to create a linear regression based off of that. And then later we're going to see how well that regression does when we add more information by taking the other 20% and testing it against our linear regression that was based off of our training set. So it's kind of a lot, but basically it prevents overfitting and underfitting your line to make sure that it's more optimal, and it gives you an idea of like what happens when you add more information to your data set. So we're going to set it to 0.2. If you want to do like a little bit more, like let's say you have a really, really big data set and you think that you can probably just test 25% instead of just 20%, you can just go ahead and add 0.25 instead of 0.2. If you want like 30%, you can do 0.3. Really up to you. Again, this is just a percentage of the data that you're creating as a test. And then the other portion of it is just going to be in your training set. A good idea, unless you're like, very rarely will you ever have to use more than 30% of your data as a test size. In fact, I highly recommend keeping it at like 0.2 or 0.25. Those are pretty good ranges. Anything above like 0.3, you're starting to get into a point where like your data is going to you're just not going to have a very good linear regression. And so, and anything less than that, if you're doing like 0.1, you're also not going to have a very good linear regression. So you want to have a good balance. 0.2 to 0.25 is a pretty good range for that. So then lastly, we're just going to create, just do one more thing, random underscore state equals 0. And in some linear regressions, having like a random number generator kind of helps helps with your linear regression. We don't need any random numbers or any randomness in our data. We're just trying to evaluate what we have. So we're just going to go ahead and set it to 0. And that just kind of eliminates all the randomness in our data. So now that we're done with that was a lot, I know, but we're just going to go ahead and execute that, run it in our code. And if you get this warning, I get this warning all the time. It doesn't mean anything. Like, it's just a warning. It's not actually saying that there's like an issue or that there's a problem or there's like a bug in the code or anything. It's just simply saying like an issue could occur if you continue with your data setup like this. So don't worry about it. It's not a big deal, especially for the purpose of your linear regression. That's more for like if you're going even more into like cross-validation. So don't worry too much about that. After this, we actually need to create the regression. So all of this was pre-processing our data, making sure that we could, create a data set that we can create a linear regression to. The next step is actually creating the linear regression. And we're not going to see it yet. Later, I'll show you how to like visualize and, make a graph that actually shows the linear regression. But this is just going to create the linear regression in the computer, and we can kind of see some numbers and compare them. So first, we have to do something similar. We have to do another from sklearn, except we're going to do it a little bit differently. So from sklearn dot linear underscore model, import linear, and make sure that you capitalize the L, linear, and then capitalize the R, regression. There you go. Perfect. And then this is where we get a little bit different from above. We're going to create first a regressor equals, and then just call the same thing. So linear regression, and then parentheses. So it kind of looks like we just basically did the same thing over again, but this is super important for like when we actually use it in a second. We don't have to put anything in the parentheses like we did up here. All the defaults for this, and if we want to, we can check again, Control I. It'll show you all the presets, but all the defaults that we want are already set. So default true for the fit intercept, normalize is also set to false as well. So we don't have to change anything. After that, we're going to call the regressor again. So regressor and then dot fit. And we're going to put x train underscore y underscore train. and then we'll execute it. Okay, and so what this section does, again, Control Enter, what this section does is actually makes the linear model. So again, like I said, this was all just getting it ready for the linear regression. What this section actually does is it created a linear regression. So our linear regression is technically done. We just obviously, like right now we can't see it. So now we're going to work on actually creating a visual and like creating a data set so we can see the numbers. But our linear regression is done right now. And this .fit just says like, hey, take this process called linear regression and create a linear regression based on our X train set and our Y train set. And then now what we're going to do is create a Y prediction set. So ypred equals regressor.predict. And we're going to say X test. And then go ahead and execute this. By the way, this part says it's red and it says out. That doesn't mean anything. Just the input for Python is blue. When things are outputted, it turns out red. And so just because it's red, it looks kind of scary. It doesn't mean anything. It just says this is what all of our settings are set to. So now that we've created a Y prediction, we can actually go ahead and look at our variable explorer. So what we're going to do is we're going to look at what we said is, hey, okay, so now that you have this linear regression, test the linear regression and see how accurate it is by taking our our X test set and guess what the Y variable would be for those numbers. And what we can do is we can look at the Y prediction, pull that out, and even pull out the Y test. And what we do is we can kind of just like look at them and compare them a little bit. Okay, so sorry, my audio wasn't working really well. So where we left off, we created our Y prediction, and we are now going to look at our prediction and compare it to the actual results and see like how close they were. So when we put in our X input in our test set, we guessed that the value for Y would be 332.75, and what the actual result is 347.52. So that's not too bad. That's like what, like less than 20 off. Especially out of 350, that's a pretty decent guess. We're a little further off in our second guess here. It says 326.18, and what it actually was is 361.67. But that's that's traditional with regressions, and so like we can kind of look at this data and say like, okay, let's see here, like, oh wow, our fifth variable was like really close. Like they weren't even $1 off. They were like 30 cents off of the actual price, which is really impressive, right? So if we can see that as like a pattern and we can go through this data and say like, wow, that looks, pretty close, that's great. But the problem is that there's so much data here that, going through this obviously takes too much time. So what we're gonna do is learn how to actually visualize this. And I'm not gonna teach the coding for this. I'm just gonna copy it. I've actually created a separate file here. So we're gonna create this, Control-C, and go ahead and paste this. And I'll talk about it a little bit, but I'm not going to go super in depth with it. This is just what matplotlib does. It helps us create visual graphs of our data. And so go ahead and just copy this information. You may want to change, your labels. I just made a generic stock versus market. And whoops, I messed up here. Let's see, market, and this is going to be our stock. Let's see, our stock. But as you can see, these are just our labels. So it'll say like stock adjusted close, market adjusted close, and stock versus market regression. You can change those if you want to make them more tailored. And then these here are just the colors that our points are going to be in. So if you want to change, like there's a green, yellow, black, gray, white, you can graph it whatever colors you want. Just make sure that you type them in these parentheses here. So like one thing I like to do is if you have like a dark green color or something, if you want to make more accessible and for people who have like who are colorblind or have visual impairment, you can change the colors. But I'm just going to go ahead and go with these colors right here. So let's see here. Yes, so everything is set up. We've got our everything's ready to be plotted. Again, just go ahead and copy this. You don't have to worry about how it all works. And if I hit Control Enter, we can actually see our graph, and that actually looks pretty good. So these red points are our data points, and if we look, the blue line goes pretty straight through it. That looks like a really good regression. And so it also makes sense that when we were looking at our predictions for our Y, it made sense that some of these were kind of over, some of these were kind of under, but overall they seemed relatively close. And so that was our training set. So now let's go ahead and see what our test set does. So again, this one says like, okay, so they're going to use all these points and then create a linear regression. And what this next plot is going to show is, okay, now let's throw in some new data points and see how well it still works. And so let's go ahead and control enter. And yeah, like it looks almost exactly the same. There's less data points, obviously, because this says 80% of the data, this says 20% of the data, but it looks almost exactly the same, like the same pattern, the same correlation. And so it makes sense that our linear regression is pretty decent. Something you may want to consider, though, is that this data set, for this stock, it isn't a straight line, but it actually almost looks like a curved line. And so maybe you might want to consider something else, like, say, polynomial regression, which I'm not going to teach. But later, if you want to learn more, a polynomial regression would be much better because it would actually match the curve to this. And you could see, like, okay, this is the actual regression of it. And you could get a much better idea of what your data is doing. But for the purpose of this video, this still looks like a pretty good linear regression. We don't have to worry too much about it. But yeah, so I'm going to teach two more things, and then I'm going to talk about, because you're probably looking at this and you're like, this is a lot of stuff. I'm going to talk about why Python is really useful and when you should use it and maybe when you shouldn't use it. So let's go ahead and add a couple more things here. First of all, let's say you like the picture. The picture looks great. The only thing is that you want to actually see the numeric formula for this blue line. You're like, I need to put this into a paper, or I need to put this into a report, and I need to actually use numbers. I can't just use this picture. You can actually print out, Python doesn't show the exact formula for this equation, but what it does give you is it gives you the individual parts for it. So remember, the equation for a line is y equals mx plus b, if you've ever taken a high school class. And so what we can do is we can tell it to print out the m, which is the slope, and then print out the b, which is the intercept. And then we can just create the formula based off of that. So if I say print, and then in parentheses, type in regressor dot coef underscore, that's going to print off the coefficient. It's going to, in this section right here, it's going to show us the coefficient of our equation, which is the m, the slope. And then if we want to see the intercept, we say print, and then again in parentheses, regressor dot intercept underscore. And again, the underscore is really important because it's not going to work if you don't have that underscore. And it's also not going to work if you spell print wrong. There you go. So once we highlight this and once we push Control Enter, we're actually going to get the two numbers. So let's go ahead and do that. Control Enter. And here you go. Here are our numbers. So it's 0.2861, etc., and then negative 469.1168, etc. So what our equation would be for this line would be 0.286x minus 469.11. And that would be our numeric formula. So you could easily type that in to your equation. This is really exact, obviously. So that's what Python's really good at, is getting really exact. It goes out like 8 digits, 10 digits, something like that. So this is like a pretty exact formulation. The other thing that I want to teach you before this, before we go into like just the reasoning why Python is better, and or at least in my opinion, I'm going to teach you a little bit more. So if you are looking at your line and you're like, I want to know a lot more statistical information, or for my assignment or for my report, I need to know like what is the standard error, or what is the p-value, or what is the r-squared of this equation, we can go ahead and type that as well. We just have to redefine our regressor, which is really simple. So first we're going to import, so from actually, I'm not even going to teach it. I'll just go ahead and copy this, and I'll just show you about it. Sorry, I don't know why I was saying sklearn. There you go. Okay, so import statsmodel.formula.api, and again, we're just going to say as sm, because you could type statsmodel.formula.api.ols, or you could just type in sm, and for me, that's a lot easier. You can go ahead and set up your ndog and your xog the same way. It'll still work for your data as well. And then regressor.summary, and what this summary does is it's actually going to show us the statistical information. So this like fits our regressor to it basically finds all of the statistical information of this, and then this will display it for us. So go ahead and highlight it all, and then Control Enter, and then there you go. So as I said, if you want your r-squared or your adjusted r-squared, or if you're looking at your x variable and you want to know like the coefficient of it or standard deviation, it gives you all this information. And so this is useful, again, if you need that extra information about the statistics of your model. I use it a lot. I think it's really helpful, especially when I'm working on like finance papers or something like that. So there's a report. There is your graphs. There's your equation. You basically have everything that you would probably need. So I'm going to go off just a little bit more, just explaining like why I prefer Python over Excel. And, there are reasons why Excel is great and then reasons why you should probably switch to Python. And so the one reason why Python is a little bit better is because that having lots and lots of data takes up a lot of space on your computer. And if you're running, if you have an Excel sheet and you have thousands and thousands of rows of data, your Excel sheet is going to be really, really slow. And so it can still do like the regression. It's just going to be really, really slow. It's going to, be a lot harder to work with. Whereas like with Python, it doesn't have that problem. It's really quick. You can run through thousands and thousands of rows of just raw data, and you're able to, pre-process it pretty quickly. And then on top of that, use some kind of regression analysis on it. Okay. So the other reason why Python is super useful is that it allows us to do multiple analyses pretty rapidly. So for instance, if we want to do a linear regression in Excel, for instance, for one stock compared to one market index, that's totally fine. That's pretty easy. We could just download the two Excel files, copy the data from one Excel file and put it into the other, condition the adjusted closing price to, instead of saying just the price, we actually say the daily return, and then we do the linear regression on that through some of the Excel functions. It's pretty easy. It's pretty quick. But if you have to do that for another stock, for instance, let's say you're going from Boeing and then you want to do it on Intel. So if you want to do that, you have to do all of that over again. And then let's say you're doing that, for 10 stocks or 20 stocks, or, it's your job as a, some financial analysis or financial analyst to go through all these different stocks and see like which one is going to be best for the next, considering the market condition that you're predicting. It's going to take a really long time because you have to do everything from start for every single one. However, with Python, all you have to do is you can use it. Everything in here is almost exactly the same. All you have to do is just download the data set, put it into the same file, and then change the CSV. So for instance, if I wanted to do, say, Intel, and in fact, I downloaded Intel, and all I have to do is go to my downloads, take Intel, move it to the same folder. So as you can see, the Intel is in there. I'm going to change it to, just rename it to Intel. There you go. Now if we look here, we can see intel.csv is right here. All I have to do is just change this to Intel. And then boom, highlight it all, Control Enter. There you go. Now I have my data analysis. So much quicker, so much easier, and that's it. That's all you have to do. And so as opposed to doing this for, starting over from the beginning, we can just save this entire file, move our different CSV in there, and then just edit it. So that's all that we have to do. It does make our lives a lot easier. I'm not sure. There's a small error that popped up here. I think I just didn't highlight it right. Let's see here. Let's try that one more time. Matplotlib has no attribute label. Oh, title. Maybe that's probably the issue. Title. There you go. Sorry, my bad. But there you go. So if you label all this stuff, there you go. There's your stock adjusted close, market adjusted close, your stock market regression. But there you go. As you can see, this works so much easier for us, and we're able to see, all the data a lot more quicker, and we can do this multiple times for multiple different stocks. So that's why I prefer Python. Sorry, that was my little soapbox speech of why I prefer Python. It's just in general, it's a good skill to have, especially the market is beginning to demand it a lot more. So I highly recommend it for the purposes of, for instance, if you're watching this and it's for Finance 425 at WSU, and you just have to do one stock, sure. Excel might just be a better idea just because it's quicker. You don't have to really worry about learning all this stuff and downloading all these new softwares. You can just do it in Excel. But again, if you're going to be doing this because you're interested in specific stocks and you have some information that, the stock market might, go down, there might be a correction, or, the stock market may be favorable in the future, you can look at what stocks are going to react better to that condition. So I highly recommend it. It's a good skill to have. But other than that, there you go. We have officially done linear regression in Python. We have all of our statistical information available. We have our formula, and we're done. So thank you for listening, and have a good one.